Hello everyone. So we are going to go with the second version of our chapter sets, and we are going to clear certain topics on the chapter sets that are: first one, set builder form; second one, types of sets, and then we'll be talking about subsets and how to represent intervals. That is an important part. And then we'll be talking about universal set and how do we use power sets as well. So these are the certain topics that we'll be covering today. But then before starting any of the topics, we have to practice maths daily. That is one message that every teacher sends you. But if you practice maths daily, it will be easy like drinking waters. Otherwise, it'll be like chewing stones. So with that, on that note, I'll be beginning today with the first topic to be covered, that is set builder form. So in the last topic that we covered, we talked about roster form and how it is represented, all right? Usually between the braces as it is, all right? So next we are going to talk about set builder form, okay? So to understand set builder form, let me give you a question first. Represent the given set 11, 17, 19, and one more number, sorry. (11, 13, 17, and 19). Okay? In set builder form. And that is the question. All right. Now we have a set over here that has elements 11, 13, 17, and 19 in the form we know as roster form. Okay. So this form has to be converted into set builder form. So to convert a certain set into set builder form, we should know that there should be certain nature to the elements of the set. Okay. For example, in this case, the underlying nature should be that these numbers are what? Prime numbers. Okay. All right. 11 is a prime number, 13 is a prime number, 17 and 19 as well. Second, we need to know is the limitations in which the numbers are underlined. So the limitation is it is greater than 10. And over here the limitation is it is less than 20. Okay. Now we get two things. First, the nature and the limitations. Now using these two things, we can represent the given roster form set in set builder form. So the answer should be set A is every element is X such that X is a prime number and what kind of prime number? Greater than 10, less than 20. Okay. So this set in the roster form is converted into set builder form with a guiding character and underlying limitations. Simple. So using these two conditions, we can easily convert any roster form into set builder form. For example, again, I'll change the set given to a more easier set. Let's say certain alphabets. I've got I, T, E, B, T. All right. Now this is a set A that has elements X such that X is the characters of word Tibet. Okay. Simple. All right. So this is how we convert a given set into a set builder form. Easy. Next, we are going to talk about types of sets. Types of set. Okay. So first type of set, which is a very important set, and it is known as null set, also known as void set. Okay. And it is represented by phi. As in physics, we represent it as flux. All right. So mathematically speaking, a null set is a set that has zero elements, without any element. For example, what can we say? For example, in a Tibetan society, a person who does not speak Tibetan. So that would not be possible, and such set would be a null set. Okay. Second type of set, we have singleton set. Okay. What is a singleton set? It is a set that contains only one element. All right. Third type of set, we have null set, singleton set. We have equivalent set. Now, what is equivalent set? Before understanding equivalent set, we should know what is cardinal number. Cardinal number. Cardinal number is nothing but the count of the elements in a given set. For example, in a set A, let's say the elements are 1, 2, 3, 4. Okay. Now, what is the count of the elements in the set A? We have certain elements. How many elements? 1, 2, 3, 4. Total 4 count of elements. All right. So total 4 elements. That means the cardinal number of set A is equal to 4. Similarly, let's say set A has elements A, B, C, D. So, what are the number of elements? 1, 2, 3, 4. Again, the cardinal number is how much? 4. Simple. Now, if we compare two sets, let's say set B, whose element is 1, 2, 4, 7. Okay? Clear? Now, the elements of set A, the cardinal number is 4. And for the elements of set B, the cardinal number is again 4 elements. So what happens is the cardinal number in both the sets are equal, which is equal to 4. Therefore, these two sets, sets A and set B, are known as equivalent set. Simple. Now coming to fourth type, we have equal set. What is equal set? Two types of sets or two given sets whose elements are same. 1, 2, 3 and 4. And then we have set B, which is say 2, 3, 1 and 4. So what happens? All the elements are correlating. 4, 4. 3, 3 and 2, 2. Since all the elements are same, the cardinal numbers are also same. Therefore, set A and set B are what? They are equal sets. Now, the next type of set, we have finite set, which is the fifth set. So, by finite set, the name itself suggests we know what a finite means. For example, we have a class 10th and we make a set of all the students in the class 10th. Let's say class 10B, we have 35 students. Therefore, the finite set will consist of 35 students. The last set that we have is infinite set. So in infinite set, as the name suggests, the list should be infinite. For example, a set of all the natural numbers. Obviously, it is going to be an infinite set with a number starting from 1 to ending unknown infinity. So that way, the all types of set we have discussed. For example, first set was null set. Second set was singleton set. Then we had equal set, equivalent set. Then we have finite set, infinite set. Okay. Next on the list, we have subsets. Now, this is an important part of the chapter. What is a subset? Okay. By the name itself, it suggests that it is a part of a set that was already given. For example, let's say A is a parent set with elements 1, 2, 3, 4. Okay. The cardinal number is 4. All right. Now, if we talk about the subsets that originate from the set A, then we can call A to be a parent set whose offspring is a subset. Okay. So, let's say B is a subset. Now, B should contain the elements that A has, not necessarily all the elements, but if the element that is not inside the set A, then the B would not be a subset of A. Clear? All right. So, for example, if I write 2, 3, then we can clearly see that the elements of B, the elements that belong to B, also lie in the set A. All right. Since this is true, therefore, B is a subset of A. Clear? Or we can write that A contains B and A is the power set of B, or you can say superset of B. Okay. So in this way, we can write it as subset of A or superset of B. All right. Now that being said, how many subsets can a set possess? Okay. Now to understand this, we need to know cardinal numbers. We already did that. So in a set A, the cardinal number is how much? It is 1, 2, 3, 4. It has 4 elements. Therefore, cardinal number of set A is 4. Clear? Now, since cardinal number of set A is 4, therefore, the number of subsets that it can have would be equal to, this is a formula which states the number of subsets any set can have is 2 raised to the power cardinal number. So, for example, in this case, the number of subsets that A can have, will have, would be equal to 2 raised to the power 4, which is 16. So, this A set can have 16 subsets. Okay. Now, the question is how? So, to begin with, we need to know certain properties about the subset. So, the first property. Every set is a subset of itself. Okay. So, for this set A, that implies A is a subset of A itself. Simple. Second, we have that null set is a subset of any set. So, any given set has a subset in the form of a null set. Okay. So, we can write phi is a subset of A in this case. So, keeping these two in mind and the formula to find the number of subsets in mind, we will try to find all the subsets of a given set. For example, let's take a set B that has elements A, Let's take elements alpha, beta, and gamma. Okay. Now this is a set that has 3 elements. Therefore, the cardinal number is how much? 3. All right. Now the cardinal number being 3, therefore, the number of subsets that it can possess would be equal to 2 raised to the power 3, which is 8 subsets. Clear? Okay. So simply to put forward, let's find the subsets. Okay. So we have first subset would be let's put forward the first rule that a null set is a subset of any set. All right. So let's say first subset is null set. Second subset would be alpha singleton set. Okay. Second subset would be beta, another singleton set. Okay. And then fourth subset, gamma. All right. What more can be formed? Alpha, beta together in a single set. Beta, gamma in together set. And then gamma, alpha in another set. Okay. Now how many sets we have made? 1, 2, 3, 4, 5, 6, 7. One more remaining. And the last one would be our first property, that's set. Every set is a subset of itself. So in this case, the last subset would be alpha, beta, and gamma. All right. Now these are all the subsets possible out of this set B. All right. And counting them all, we have 8 subset to be exact. Is it clear? So from this subset, we can say first subset, okay, all the elements in this subset and all the elements in this subset are not same. Okay, only one element is same, even though, okay, but rest of the element are not same. Therefore, we can write that this set, which is null set, is a proper subset of B. Okay. However, in the last subset, we find all the elements are same in set B. Okay. Alpha, beta, gamma, all the elements are same. They correlate to each other. Therefore, we can write that this set alpha, beta, gamma is not a proper subset of B. Okay. So this being said, there are 2 conditions. First one is proper subset and second one is improper subset. Even though it is a subset, but since all the elements are same, therefore it is an improper subset. It is a proper subset as long as all the elements are not same. This is also a proper subset. This is also a proper subset. This is also a proper subset. Same thing with this and this. However, this one is improper subset. Reason being, all the elements are same. Okay. In this case, there is no alpha. There's alpha over here. So all the elements are same, even though 2 elements are same. All right. So this is a proper subset. However, this is improper subset. Okay. Simple. So next we are going to talk about intervals and its representation. So there can be usually 3 intervals in mathematics. First interval is closed intervals. Second one is open intervals. And third one is semi-open or semi-closed. Okay. Now, the topic itself is not as important as the figure or the statement in which way it is written. That is also important. So, for a closed interval, you have to see this carefully. We represent in form of square brackets, a comma b. Okay, and for open intervals, we represent it through common brackets, a comma b, and then for semi-open or semi-closed, we represent it as a mixture of both the brackets, a comma b. This one would be closed. Okay. Now, what does this imply? This square bracket and the common bracket. In the square bracket, what it means is the value of this is such that it includes all the values between a and b, and given a included and b included as well. Okay. So, what does it mean is x is such a value that is greater than equal to a but less than equal to b. Okay. So, this interval includes a and b as well. Therefore, it is known as closed interval. For second condition where open interval is concerned, we write x is greater than a but less than b. So, in this statement, what it says is x is a value such that it is between a and b, but it cannot be equal to a, it cannot be equal to b, however, certain value between a and b. Alright, is it clear? And for the last one, it states that the x value is greater than a, but less than equal to b. Okay, so in this condition, b can be included. Same way, it can be written as this implies same thing. Okay, and it can also be written in this way: a included, b excluded, or a included and b excluded. Simple. Is it clear? So for the next set topic, we have universal set. So what do you mean by universal set? It is a parent set from which certain offsprings are obtained. Or we can say, take example, let A be a set 1, 2, 3, 4, and let B be another set with certain values A, B, C, and D. Then, in this case, a universal set would be a set that contains all the elements of A, 1, 2, 3, 4, included with all the elements of B as well. So this means that universal U is a parent set that contains set A and set B. Okay, clear? Now for the last topic for today, we were talking about power set. What is a power set? Okay. Now power set is defined as a set that contains all the subset of a given set. Okay. If it's confusing, let's write it down. What is a power set? Power set is a set of all subsets of a given set. Okay. Now this is the definition of power set, but what does that mean? Let's write it mathematically. Let's say we have a set, say X, that has elements A, B, and C. Okay. So before writing it down, let me ask you, how many subsets will this set X have? So quickly we can calculate that it is going to have the number of subsets equal to 2 raised to the power 3, which is equal to 8 subsets. Simple. Okay. Now, since it's going to be having 8 subsets, what are those 8 subsets? The subsets would be, as you remember earlier, null set. Okay. Next one would be singleton set A, singleton set B, singleton set C. Now combine them together. A comma B, B comma C, C comma A as well, and then last set is A comma B comma C. Alright. Now these are all the subsets of the set X. Simple. Now what is power set? So as the definition goes, power set is the set of all the subsets of a given set. So in this, the given set is X. Okay. So the power set of the given set X is equal to all the sets in braces. So from this, we are getting power set. These are all the subsets of the set X. So next we are going to talk about the application of power set. For that we have a question over here. The question is, you have to find a set X such that the set X is a proper subset of B and X is a proper subset of C. Alright. Now we have certain values given where set A is A, B, C, D, and set B is A, B, C, and set C is B, D. Simple. Now you need to find a set X such that it is a proper subset of B and C as well. So to find that, what we'll use is, we'll use the method of power set. So what we need to do, we have to find the power set of B. Okay. So what is the power set of B? Equals to a null set. As always, we have singleton set A, B, and C. Okay. Likewise, we have combination of AB, combination of BC, and a combination of CA. And the last one, the set itself, A, B, C. Set being closed. Alright. Similarly, we can find the power set of C, which is equal to, again, a null set and set B. Okay. Simple. Similarly, set B and then combination of set B and D. Full closed. Okay. Now this set X is a certain set whose element corresponds to B and C as well. Alright. So to find that set X, we need to find the power set of B and C and then compare them. Comparing them, what we have in common is null set and set B. Simple. Anything else common? As we see, there's nothing else common. So these two are the only parts that are common in both the sets, both the power sets of B and C. Therefore, we can write set X is equal to a set of null set and set containing B. So this should be the answer. Alright. Now for your practice, I'll twist the question slightly and I'll be writing find a set X such that set X is a proper subset of B and X is a proper subset of A. Alright. The method would be same. However, in this case, instead of writing C, I'll be writing A. Now this is a question for you to solve. Thank you for today.